Good morning, students. The voice is audible. Are you able to listen me?
Yes, ma'am.
Yes, ma'am.
Okay. Let's just try this projector. Okay. You have to push that orange button. Not working. It's not working. Not projecting. Can you log into your system? I'll complain about this again. So, we begin with the testability of sequential circuits today. Till now, we talked about combinational circuits. And when we talked about combinational circuits, we had certain inputs available to us, which we called primary inputs, जिनको हमने capital letters से indicate किया था A, B, and we had certain outputs, which we called PO, primary outputs, right? So what we did was we tried to have a fault in the combinational circuit, and we try to observe that fault at primary output and justify those values towards primary inputs, right? But now what happens when it comes to sequential circuits, you have at least one flip-flop. We consider a D flip-flop. The input to the flip-flop is D, the output is Q, and it runs on a particular clock. So the output of the combinational circuit is used as input to your D flip-flop, and the output of this D flip-flop is considered as one of the inputs to the combinational circuit, right? So if I look at this circuit now, in the combinational part, I have only this as PI, this line as PI. This is the input to the combinational circuit which I obtained from the flip-flop. Come in. So we call this as secondary inputs, or we call it pseudo primary inputs. The projector is not working, so you need to log in into your devices. So my combinational circuit now not only has a primary input, but it has some secondary inputs as well. Similarly, the output. No more we have primary output. But this output, which was earlier a primary output, which I could see at the output of the circuit, is no more visible to me as an output, but it becomes the input to my D flip-flop. We say this becomes my secondary output or pseudo primary output, PPO, PPI here. The advantage of having the observability and controllability for the combinational circuit was that I was able to read the output clearly, whether the fault has been propagated or not. Also, I was able to identify what should be the value of PI, right? But now, जैसे circuit में flip flop आ गया, I do not know what is its previous state. 0 भी हो सकती है, 1 भी हो सकती है. Right? Flip flop की initial state can be 0 or 1. So अगर मैंने 0 माना and I put a clock cycle here, clock edge here, this 0 will be propagated and the secondary input will be read as 0. Right? But if the previous state of the flip flop was considered as 1, now the secondary input becomes 1. So I am not able to control this secondary input as it is. जैसे प्राइमरी इनपुट में तो मैंने कह दिया कि इसका वैल्यू 0 रख दूं मैं या 1 रख दूं, सो आई वाज एबल टू कंट्रोल इट. बट द सेकेंडरी इनपुट आई एम नॉट एबल टू कंट्रोल इट बिकॉज दिस इज गिवन एज द स्टेट ऑफ फ्लिप फ्लॉप. सिमिलरली अगर कोई फॉल्ट यहाँ पर है and this is not given directly to this primary output but it is given to the secondary output, the fault is no more observable. I am not able to observe the fault at the output of my circuit. Right? So to overcome this problem, we study these sequential circuits and we try to reduce these sequential circuits to some combinational equivalent. So that जो भी हमने combinational circuit के लिए processes पढ़े हैं, D algorithm पढ़ा है, path sensitization पढ़ा है, those algorithms can directly be implemented on those combinational circuits. In general, the sequential circuit is distributed into two parts. One is called the next state function, which defines, we call it as NSF, which defines the next state of my flip-flop, which runs on a clock. Say D and the output is Q. The output becomes the secondary input or I say pseudo primary input. Other than the pseudo primary input, I should have a primary input. Right? This becomes my secondary output. This secondary output becomes the input to my flip-flop. ठीक? अब मेरा एक output clock भी होता है, where I have some inputs given, primary inputs. इसको हम कहते हैं output function block, OFB. And this gets the primary input as well. So from here, this is getting some primary inputs so that I am able to observe the output here. Right? This is a combinational circuit. This is a combinational circuit. Only the task left is to consider this flip-flop or to transfer this flip-flop into its combinational equivalent. It means somehow I need to have this pseudo primary input controlled. Not only primary input, I want pseudo primary input to be controlled. Pseudo primary input कब control होगा? जब मेरा secondary output में control कर सकती हूँ. It means somehow I should be able to control the value here at the input of the flip-flop so that it is no more an X. राइट. सो इसका मतलब ये जब क्लॉक साइकिल आए एंड द वैल्यू गेट्स प्रोपोगेटेड, उससे पहले आई एम रिक्वायर्ड टू कंट्रोल द सेकेंडरी आउटपुट. ठीक है. अगर मैंने ये कंट्रोल कर लिया तो क्लॉक जब आएगा देन माय प्राइमरी आउटपुट, सूडो प्राइमरी आउटपुट इज आल्सो कंट्रोल्ड. सो इट मींस एक टेस्ट पैटर्न will be required to control this secondary output before I control this primary input. So combinational circuit में एक fault के लिए एक test pattern was sufficient. But in my sequential circuit, if I want to control all the inputs of my NSF, I need to have at least 2 test patterns. एक test pattern तो इस flip flop का input set करेगा, दूसरा टेस्ट पैटर्न प्राइमरी इनपुट्स को सेट करेगा. सो द नंबर ऑफ टेस्ट पैटर्न इज इंक्रीज्ड. अभी सर्किट में एक फ्लिप फ्लॉप है तो एक साइकिल एक्स्ट्रा लगा. अगर दो फ्लिप फ्लॉप सीक्वेंस में हो जाएंगे देन आई विल रिक्वायर समथिंग लाइक दिस. इफ दिस इज फ्लिप फ्लॉप 1 running on a particular clock followed by another flip flop running at another clock. So I will assign some value here, let's say D. That D will be propagated on first clock edge to the output of flip flop 1. But at this point, at the same clock edge, value here was not D, it was X. It is assigned D after the clock edge. तो इसका मतलब अब इस D को फ्लिप फ्लॉप 2 के आउटपुट पर आने के लिए मुझे फिर से एक क्लॉक एज चाहिएगा. सो इट विल बी ट्रांसमिटेड टुवर्ड्स द आउटपुट आफ्टर 2 क्लॉक एजेस. सो इट मींस आई नीड टू स्पेसिफाई मोर देन 2 टेस्ट पैटर्न्स नाउ. एक टेस्ट पैटर्न यहाँ के लिए, दूसरा टेस्ट पैटर्न यहाँ के लिए, तीसरा टेस्ट पैटर्न यहाँ के लिए. So as my number of flip-flops increase in the sequential circuit, the number of test patterns required to test the faults in the sequential circuit also increases. So this becomes more complex as compared to combinational circuit. We call this method as time frame expansion, because we are expanding the time frame for testing the fault. ठीक है. जो हमने कॉम्बिनेशनल सर्किट में काम किया वो केवल यहां पर किया. वी स्पेसिफाइड द प्राइमरी इनपुट्स सच दैट फ्लिप फ्लॉप की हमने सारी स्टेट्स असाइन कर दी है. बट नॉट ओनली दैट, आई नीड टू एक्सटेंड माय टाइम फ्रेम 2 cycles backward if I have 2 flip flops so that I am able to test my sequential circuit. This is called time frame expansion, right? Some assumptions are already made for sequential circuit testing. However, under these assumptions also, if we analyze for stuck-at faults only, single stuck-at faults only, we are able to get a good coverage above 90%, right? Good fault coverage. So for that, we consider that only a single clock is used. How many flip-flops I have, but all the flip-flops are synchronized. They are running on a single clock. राइट. सिंगल क्लॉक का एडवांटेज क्या है? दैट आई एम एबल टू आइडेंटिफाई कि किस टाइम पर मुझे इनपुट पैटर्न्स को देना है. अगर इसका क्लॉक अलग चलेगा, इसका क्लॉक अलग चलेगा, देन इट विल बी नॉट पॉसिबल फॉर मी कि ये वाला टेस्ट पैटर्न कितनी देर तक अप्लाई करना है. राइट. सो टू सेव दैट टाइम वी कंसिडर दैट ओनली अ सिंगल क्लॉक इज यूज्ड. ऑल्सो the flip-flops that we are considering, these are simply 1-bit memory element and a D flip-flop. Not JK, not SR. We are only considering the D flip-flop because memory elements are made up of D flip-flops. All flip-flops are synchronized with one clock and the data is transferred to flip-flop output after the clock edge. Maybe the rising edge or the falling edge. For the time being, we'll always consider the rising edge. जब भी क्लॉक का राइजिंग एज आएगा देन ओनली द डेटा विल बी ट्रांसमिटेड फ्रॉम इनपुट टुवर्ड्स आउटपुट ऑफ योर फ्लिप फ्लॉप. देन द फ्लिप फ्लॉप faults, no fault is considered inside the flip flop. If it is a D flip-flop, it should be made up of certain transistors, it should be made up of certain gates, but we are not considering any fault inside the flip-flop. We are only considering the stuck-at faults at the inputs of flip-flops and at the outputs of flip-flop. However, even this condition, if the input and output stuck-at faults are considered only, still we are going to get coverage of above 90%. In fact, around 99% we are able to get for certain circuits, right? So this is not important if the fault exists inside the flip-flop. We are only modeling the faults outside the flip-flop. Also, there is no fault which is considered in the clock signal. The clock signal is perfect. No delay, no stucking fault at clock. In these conditions, we look into the first sequential circuit, a very small circuit, which we will analyze to find the test pattern, how to detect the fault. If I compare it with the block diagram of NSF and output function block OFB, look at this OR gate. OR gate पर एक तो प्राइमरी इनपुट आ रहा है, राइट? दूसरा इनपुट OR गेट पे कहां से आ रहा है? फ्लिप फ्लॉप के आउटपुट से. तो कंपेयर इट विद दिस डायग्राम. एक प्राइमरी इनपुट आ रहा है और दूसरा फ्लिप फ्लॉप का आउटपुट आ रहा है, राइट? In OFB, I am getting a primary input and the output of the flip flop. But OFB का output becomes my primary output, NSF का output becomes my secondary output. So compare here. The output of this OR gate is directly observable here as primary output G, right? It means this OR gate works as an OFB, output function block, right? This is the block which is giving me a primary output. Look at the AND gate. AND gate is getting one of the primary inputs B, and another input of the AND gate is obtained from the output of your flip-flop. But the output of this AND gate is not observable. I am not able to get it at the output. It means which block this represents is NSF. I am getting a primary input, I am getting a secondary input, but the output of this block is not observable directly, right? So this becomes my NSF.
So D is the secondary output.
D is the secondary output. This becomes my D is secondary output. E becomes my secondary input. वापस बता. When you look at this OR gate का एक इनपुट तो हो गया प्राइमरी इनपुट A, दूसरा इनपुट F कहां से आ रहा है? आउटपुट ऑफ फ्लिप फ्लॉप. सो इफ यू कंपेयर इट विद दिस सर्किट, NSF में एक इनपुट प्राइमरी है, एक इनपुट D फ्लिप फ्लॉप के बाहर से. OFB में भी एक तो प्राइमरी इनपुट है, दूसरा फ्लिप फ्लॉप के बाहर से. ठीक है, दोनों ब्लॉक हो सकता है वो, लेकिन कौन सा ब्लॉक है? OFB, क्योंकि मेरा आउटपुट ऑफ OFB इज प्राइमरी आउटपुट, while output of NSF is a secondary output. सेकेंडरी वो चीज है जो मैं डायरेक्टली कंट्रोल नहीं कर सकती, डायरेक्टली ऑब्जर्व नहीं कर सकती, राइट? तो इससे अगर मैं कंपेयर करूं, प्राइमरी इनपुट और सेकेंडरी इनपुट होना चाहिए, लेकिन आउटपुट पे डिपेंड कर रहा है कि वो OFB है या NSF है. So if I look at this circuit now, OR gate का output is a primary output. It means this belongs to OFB. So this is the combinational circuit which represents my output functional block, right? Look at the AND gate. AND gate का एक input तो primary है, that is B. Another input is secondary, which is coming from E. Right, E is fanning out as C and F, so I am getting a secondary input here. But the output D is not directly observable. right? I cannot see it at the output. This is something inside the circuit. So this becomes my next state function, right? And I have a flip-flop which runs on a particular clock. Now I try to detect this stuck-at fault at one of the primary inputs A. ठीक, अगर स्टक एट फॉल्ट है, स्टक एट जीरो फॉल्ट है ए पर, इसका मतलब फॉल्टी वैल्यू इज जीरो, द एक्चुअल वैल्यू इज 1. It means the fault D exists here. The actual value is 1 and the faulty value is 0. We indicated this with the fault D, right? This D will be propagated at the output when, what should be the value of F so that D gets propagated at the output of the OR gate? We always put the non-controlling value for the other input. Non-controlling value means अगर मैं OR gate की बात करूं तो उसका non-controlling value जो है that is always 0, because this will not control the output anymore. If I put F equal to 0, whatever is the value at A will be seen at output. तो अगर A 1 है तो आउटपुट OR गेट का 1 हो जाएगा, अगर इनपुट A 0 है तो भी आउटपुट इक्वल टू 0 हो जाएगा. सो द नॉन कंट्रोलिंग वैल्यू फॉर द OR गेट इज 0. NOR के लिए भी 0 ही होता है, so that the output depends only on the required line. AND और NAND के लिए नॉन कंट्रोलिंग वैल्यू इज 1. राइट, अब यहां पर इसका मतलब what I need is, I need to have F equal to 0. Do not read what is written below this, just understand, then you will understand what is written below it. So now what I want, if I want this fault to be propagated, to be observed at primary output, I want F equal to 0. क्यों? फिर अगर फॉल्टी स्टक एट 0 हो गया तो भी इनपुट ऑफ OR गेट इज 0 1. हाँ, and 1 and 1 is also 1, so you will not have the difference, right? The fault should be detected, so the value inside the bracket and outside the bracket should be different, then only it will be detected, because inside the bracket means faulty, outside the bracket means non-faulty, right? So I want this F to be 0, right? F is a secondary output, so I want to control a secondary output which actually can be X, क्योंकि फ्लिप फ्लॉप है, फ्लिप फ्लॉप का प्रीवियस स्टेट कुछ भी हो सकता है. सो एक्चुअली स्मॉल d इज X. जैसे ही क्लॉक एज आएगा E becomes X. I want this X to be replaced with a 0, right? So what I need is, ये क्लॉक एज आए उससे पहले D should be assigned a value equal to 0. It should no more be X, but it should be equal to 0. D 0 कब होगा? जब इस AND गेट का आउटपुट इज फिक्स्ड टू 0 somehow. How can I control it? ये जो C आ रहा है ये तो सेकेंडरी आउटपुट है, I cannot control it directly. But if I put B equal to 0, then I am sure that the output of this AND gate will always be 0. इसका मतलब मैंने क्या किया, इस क्लॉक आने से पहले, ये क्लॉक है जाने से पहले, I should assign B equal to 0. If I assign B equal to 0, I am ensuring that D is equal to 0. Irrespective of this E तो अभी भी X ही है, but irrespective of this E, I have controlled the value of D indirectly. I put B equal to 0. What should be the value of A at this time? Because I am writing the test pattern, so I should specify all the inputs. But A से कोई effect नहीं हो रहा है अभी तो, right? So A is X. So the first test pattern becomes A equal to X, B equal to 0. So X 0. X 0 जब किया, उसके बाद क्लॉक साइकिल आया, क्लॉक साइकिल से ये b equal to 0 is propagated to E. Now E becomes 0. Now if E becomes 0, this 0 will be read at F. So at this time, if I want this fault to be propagated, what should be the value that I should give to A? The actual value is 1. So the test pattern should say I should give 1 now. What should be the value of B now? Anything? Because B is no more affecting my OFB. B is simply a value which will be given to NSF and it will generate a D, but that D will not propagate until I have next clock cycle. So B का कोई भी value हो, that is not going to affect any of the input of OFB. It will simply may give a new value to D, but that does not change anything. So I can put B equal to X now. B can be anything. If it is 0, the value of D still remains 0. If B equal to 1, the value still remains 0 in this case because ये C is 0. So I am getting a 0 here. B अगर 1 भी आ रहा है तो भी D का value is 0. बाद की सेकेंड टाइम की यहाँ पे ये वैल्यू अगर बदलती अब D की during this time, if the value of D changes, that change will be propagated only after the next clock. इस clock के बाद the new value of D will be read ना. हम अभी वहां तो पहुंचे ही नहीं, हमें तो यहीं पे प्राइमरी आउटपुट ऑब्जर्वेबल हो गया. Before the clock, if you have taken that is equal to 0. F equal to 0, yes. Obviously C will be 0. So it can be 1 also. हाँ. So you have taken B equal to 0 and A equal to 1. वो तो पहले केस में. पहले केस में we have taken F equal to 0. No. We wanted F equal to 0. Look again. दूसरे में F1 नहीं होगा. नहीं. क्योंकि D propagate नहीं हुआ ना. D will go to Q after clock H. We'll redo it. This concept is important. इसको अच्छे से समझना तभी आगे सारा sequential समझ आएगा. Look, this is OFB. Initially, हर line का value is X. I do not know, right? If I want this stuck at fault 0, so it means my input should be this. Actually, one faulty 0, which means fault D, right? हम क्या करते थे? Fault को sensitize किया, फिर उसको observe करते थे towards output. When will this D be propagated to primary output? ये D कब बाहर आएगा? जब F का value 0 हो. So we need 0. Actually है क्या यहाँ पे? X. Because अभी हमने सर्किट स्टार्ट किया है. फ्लिप फ्लॉप का वैल्यू कुछ भी हो सकता है डिपेंडिंग अपॉन द प्रीवियस स्टेट. वो X है. 0 भी हो सकता है, 1 भी हो सकता है, बट आई वॉन्ट ओनली अ 0 ऑन F. हाउ डू आई इंश्योर दैट आई गेट दिस 0? जब सर्किट स्टार्ट हुआ यहाँ पे कुछ भी था, मान लो 1 था, तो अभी तो सही नहीं आ रहा मेरा आउटपुट. I want to ensure I need this F to be 0. How to get this F equal to 0? If in the previous state, पिछले time frame में, somehow I put T equal to 0 in my last time frame, before I am analyzing this NSF block, OBF block. I am analyzing OBF here. क्लॉक से पहले पिछले टाइम फ्रेम में आई सेट D इक्वल टू 0. तो OBF एनालाइज करते वक्त आई विल गेट F इक्वल टू 0, राइट? अब सेट कैसे करें हम D इक्वल टू 0? D is the output of the AND gate. I want the output of the AND gate to be stuck to 0. So at least one of the input of the AND gate should be made equal to 0. Then I am sure the output will always be 0. So the primary input of this AND gate, which is B, I set B equal to 0. सी अभी x है. हाँ, कहाँ मैंने लिखा ही. I want D equal to 0. पिछले वाले में ये पिछला हो गया, क्लॉक से पहले. राइट, I began here. To begin, I say the fault will be propagated outside OBF if f is 0. राइट, तो अगर मुझे ये फॉल्ट प्रोपोगेट करना है तो पहले f इक्वल टू 0 सेट करना पड़ेगा ना. वो कब सेट होगा, ये वैल्यू कब मुझे मिलेगा, इस क्लॉक एज के बाद. यहां पर मुझे चाहिए f इक्वल टू 0, तो इसका मतलब ये क्लॉक साइकिल आने से पहले ये जो d है इसको मुझे 0 करना है किसी भी तरह. राइट, so what I did is I put b equal to 0, which ensured d equal to 0, or which gave me d equal to 0. Now clock edge came. This d was propagated to q, so I get e equal to 0. Right? So I am getting e equal to 0, which is same as f and c. So at this time f equal to 0, c equal to 0, e equal to 0. ये जो d equal to 0 था, at this clock edge it is okay. So clock edge आने से पहले I ensured that this value d is equal to 0. Now they started to work. So clock edge आने से पहले I ensured that this value of d equal to 0, so that after the clock I get this secondary input at my OBF equal to 0 and the fault is propagated and seen at primary output. तो अब clock edge के बाद my primary output is observable या fault is observable at the primary output क्योंकि output पर अब मुझे क्या मिलेगा 1 0. अगर actual value 1 है तो input become 1 0 so the output will be 1 at the primary. If the input is faulty 0, then the input set becomes 0 0 to the OR gate and the output becomes 0. So the fault will be propagated. This is what is written over here. The test pattern for stuck at 0 fault for combinational block in sequential circuit requires, where did it go? More than one test pattern. The first test pattern is A equal to X, B equal to 0. मैंने b इक्वल टू 0 सेट किया है केवल, तो इसका मतलब a का वैल्यू कुछ भी हो, इट डज नॉट मैटर टू मी. सो एट दिस टाइम a इक्वल टू x, b इक्वल टू 0. दिस बिकम्स द फर्स्ट टेस्ट पैटर्न which I refer to as TF-1, टाइम फ्रेम -1. उस केस में टेस्ट पैटर्न बिकम x0. Then there is a clock edge and then what is my test pattern? Here I need to have this fault propagated, so I need to have A equal to 1, B can be anything. So at this time A equal to 1 and B is X. So this means my time frame 0. 0th time frame is the time frame at which my fault is observable. So at TF0 the fault is observable only if during TF-1, if I give this input test pattern so that I control my secondary outputs, right? So I required 2 test patterns to detect one fault at the primary output, right? इतना cycle चलाना पड़ा. ये तो बात हुई जब fault मेरी OBF पर हो, right? तो 2 test patterns लगे. Now it becomes a problem if my fault is at C. मान लो यहां पर है अब fault. C is my secondary output, right? अभी मैंने किसको कंट्रोल किया? My secondary, secondary output किया. E is my secondary input. So I controlled somehow my secondary output so that the fault became observable. Now we look at the condition. If I want to have some control over secondary input, secondary input is seen here C, right? अगर मुझे इस C पर कुछ fault observe करना है, C is a fan out of E, तो अगर C पर fault है, it does not mean that E is faulty, right? C is different from E now. I have a fault at C. So now if I have a fault at C, let us say stuck at 1 fault, it means the actual value should be 0 here, the faulty value should be 1. This value needs to be propagated at the output here, but for that again, पिछले time frame में I should have this value 0 assigned on C. अभी तो मैं सिर्फ ये कह रही हूँ कि यहाँ पर fault है, so the actual value should be 0, faulty value should be 1. But how am I going to put this to 0? To put this to 0, I need to have in the previous cycle put D equal to 0. अगर D equal to 0 put किया है तो Q 0 आ रहा है. But now how do I have this fault propagated? At the same time I have to have the control over B again, so that अगर fault यहाँ पर आ गया तो this should go out at the output of the AND gate. तो B का वैल्यू क्या होना चाहिए? नॉन कंट्रोल्ड वैल्यू विच इज 1 फॉर द AND गेट. अगर B इक्वल टू ये मेरा 1 हो गया तो यहाँ पर अगर 0 आया तो आउटपुट 0 होगा, C पर अगर 1 आया तो आउटपुट 1 होगा. सो द फॉल्ट विल बी प्रोपोगेटेड, राइट? लेकिन इसका इफेक्ट तो मुझे कहाँ ऑब्जर्व करना है? मुझे यहाँ तो ऑब्जर्व ही नहीं करना है D पर. इफेक्ट तो मुझे प्राइमरी आउटपुट पर ऑब्जर्व करना है. So I am basically controlling this C to get a D and again going to the cycle with C, but what happens to the primary output? Whatever value I have assigned at E is going to F without any fault because this is fan out. So I now have the value of E directly propagating to F without the effect of fault being considered in this cycle. क्योंकि fault तो AND गेट पे है, वो AND गेट का आउटपुट D पर आएगा, फिर वो नेक्स्ट क्लॉक साइकिल में प्रोपोगेट होगा. इट मींस आई विल नीड 3 टाइम फ्रेम्स नाउ. पहला टाइम फ्रेम जब आपने इसको असाइन किया, ये 0 वैल्यू को लेके आना है, इट मींस आई पुट D इक्वल टू 0. फिर एक क्लॉक एज आया and the value of D gets propagated here. So I ensured that the value read here is 0 after the first clock cycle. जब ये value 0 यहाँ आ गया, it means now the fault is implemented and the result of D is updated after the first clock. I need this result to be given out here so that E is no more 0 but D. ठीक, तो इसका मतलब सेकेंड क्लॉक साइकिल आया जब ये डी प्रोपोगेट हुआ, तो सेकेंड क्लॉक साइकिल पर this becomes my faulty value and this faulty value shows the effect here, and then I put the value of A as the non-controlling input so that this fault D gets propagated to my primary output. Right, so now I needed 3 time frames to read the fault effect at output. So controlling or observing, or you say testing the fault of OBF is much easier as compared to the fault to be detected in NSF. Jabki NSF is the main thing which is deciding the next state for your flip-flop. This is more complex. To reduce the complexity, we will improve the algebra, the 5 variable algebra that we did in the combinational circuit. We'll try to improve it with the 9 value algebra in the next class. Okay, try to give an attempt to identify what are the test patterns which you will require to detect these 2 faults, one at OBF, another at NCF at your place. ठीक है, एक बार ये समझ आ जाएगा तो फिर हम आगे कॉम्प्लेक्स सर्किट्स भी कर सकते हैं. Not at any. Only one stuck at fault at a time. Once we have analyzed for stuck at 0, I require 2 time frames. एक क्लॉक से पहले TF-1, एक क्लॉक के बाद TF0. But when I try to analyze this C stuck at 1, I will be requiring 3 time frames. One will be TF0 जहाँ पे observable होगा output. The other will be TF-1 where the value of E becomes D, and the third will be TF-2 where I ensured that this fault D is getting at small d at the output of the AND gate. तभी मेरा value C equal to 0 होगा. Right? Try to analyze this. We'll do it in the next class. Online students, any problem? Okay, so that is all for today. You may leave.
This problem from the Q, the output will be 0, fault 1 or just 0.
वापिस